Hi, in the last session, we talked about others keyword in VHDL, especially in the assignment operations, and we learned why it should be used for initial assignments or reset assignments. This is also helpful when you are assigning some values into multiple elements of a vector signal or an array type data type. Now let's talk about tri-state drivers in VHDL design. Tri-state drivers are essentials when you are working with the real FPGA hardware, and this can help you in handling input output operations. This means that beside the logic high or logic low, these input output pins are having a high impedance state. This is referred as tri state, and this allows multiple drivers to connect to a single line without interference so that we can efficiently use these input output ports as well. Note that tri state drivers are not available inside the FPGA. This restrictions means you cannot drive tri-state signals to internal nodes within the FPGA devices. Let's see how to implement a tri-state driver in VHDL. Here you can see a diagram which we are going to implement in hardware. In this diagram, you can see a triangle symbol. This is a tri-state driver. D out signal is the output pin of our FPGA that is driven by a tri-state driver. D in is the input signal of this tri-state driver, which is a STD logic signal. Alternatively, we could use a STD logic vector for multiple bit operations as well, like for data bus, etc. This enable signal controls the tri-state driver. It tells that when the output pin will be active. Now, to implement this tri-state driver in VHDL, we use a combination process block. So, our simple VHDL design would be like this: tri-state colon process dn comma enable begin. If enable equals to 1, then d out gets the value of d in, else d out gets the value of z. This is high impedance. And if and process. We start with the process declaration. Input signals d in and enable are written inside the sensitivity list so that the process can respond on these signals. If enable signal is set to high, input d in will pass through to d out. And if enable signal is set to 0, then D out will be at high impedance state. Means the output is effectively disconnected from the input at this time. In VHDL, we use this letter Z inside a single quote to represent this high impedance state. This mechanism ensures that the multiple devices can share the same output line without conflicting. If you are using vector type signal, then this Z value need to be written inside double quotes and it should be matched with the length of your vector signal. Well, it's important to remember that D out must be an input or output pin of FPGA and it should not be an internal signal. So that's it for today about tri-state drivers. This was a quick and short video, and I hope you made some understanding on how to correctly implement tri-state drivers for efficient input-output management in FPGA designs. In the next session, we will be talking about VHDL comparators. So stay tuned for the updates. If you did not subscribe till now, then please do subscribe to learn and grow community for regular updates. If this video is informative, then please like this video, comment on video, and don't forget to share. Thank you for watching.